We are going to do exercise 1.3 from chapter 1 of the book. Now we need to find the graphical solution of this LP problem. In order to do that, we need to graph the constraints first and then find the feasible region and the optimal solution. Now we need to graph 2x1 plus x2 equals 70, x1 plus x2 equals 40, and x1 plus 3x2 equals 90. So for the first one, when x1 is 0, x2 is 70, and when x2 is 0, x1 is 35. So we have the straight line from 70 down to 35. And we're going to label that because we need to remember which one is which. This is 2x1 plus x2 equals 70. Now for the second one, when x1 is 0, x2 is 40. And when x2 is 0, x1 is also 40. So we're going to have the straight line from 40 down to 40. And this is x1 plus x2 equals 40. And now the last one, when x1 is 0, x2 is 30. And when x2 is 0, x1 is 90. So we have the straight line from 30 down to 90. And this is x1 plus 3x2 equals 90. So the feasible region will be the area that all three constraints coincide. Now, for the first constraint, we have 2x1 plus x2 greater than or equal to 70. So we'll go to our graph and we'll mark the area that it is greater than or equal to the line 2x1 plus x2 equals 70. We also need to remember that x1 and x2 must be greater than or equal to 0. And we include this line here as being inside this area because we have something that it is greater than or equal to that. Now for the second constraint, we have x1 plus x2 less than or equal to 40. So we'll have something that it is less than or equal to this line. But also x1 and x2 need to be greater than or equal to 0, so we'll have this area, which is the area from our second constraint. And then the third constraint gives us the area that it is greater than or equal to this line. So we're going to trace this line and then take everything that it is greater than or equal to that. Keeping in mind x1 and x2 need to be greater than or equal to 0. Now the feasible region will be the area that all three of them coincide, all three areas. We can see that we have no such region, so in this case we have no feasible region. And so we cannot find the optimal solution of this problem.